Schrodinger's cat is a thought experiment designed by Schrodinger to put the absurdity of quantum theory into perspective. So, before we get to the cat, we have to go over a bit of quantum theory first. Quantum mechanics is the science of incredibly small particles, things like electrons, things so small that no microscope on the planet can see them, so small that they don't even act like normal particles. In fact, they act more like waves. So what does that mean? First, let's get a few things straight. A particle is described as anything with mass, and things with mass are expected to behave predictably. For example, if you throw a tennis ball at a wall, you would expect it to hit the wall and bounce back. A wave is a traveling disturbance in space and time, like sound. Waves behave differently than particles because they do not have mass. An important quality of waves is that they can interfere with each other. Here is a simple visual representation of a wave. Now, if this wave were to be struck by another wave, like this blue one, something interesting happens. They add together into this black wave. The result can be a bigger wave, smaller wave, or no wave at all, depending on how the waves overlap. This is called constructive and destructive interference. Now back to electrons. Electrons are an example of a quantum-sized particle because electrons behave like a particle and a wave. They are particles because they have mass, but they act like waves in space and time. This is called the duality of matter. Now, to make things even more complicated, electrons are restricted to live in things called states. That means that there are only certain places an electron can be. For example, in atoms, these places are called energy states. There's the ground state, the first state, the second state, and so on. Now here's where things get really fishy. Certain experiments suggest that even though electrons are restricted to these states, they can be in more than one state at the same time. This means that an electron can be here, there, and also sort of muddled in between. This is called the superposition of states, and it kind of looks like adding waves together. Okay, now let's go back in time a bit. The superposition of states theory was discovered around 1930 by a group of scientists. The theory was called the Copenhagen interpretation because it was thought of in Copenhagen, Denmark. When the idea was first proposed, no one could make sense of it. No one but Schrodinger. He looked through the scientists' math and realized right away what they were saying, that a particle could be in two places at once. He knew this was crazy and wanted to show how crazy. In order to put the theory into perspective, he decided to describe the theory with a thought experiment. Here's his experiment. Imagine we have a cat inside a box. Meow. We can't see or even hear the cat. With the cat in the box is a bomb. Meow. A special bomb. This bomb has an exactly 50% chance of exploding or not exploding. Now, the cat has two states, dead or alive. According to the Copenhagen interpretation, however, the cat can be dead, alive, or both, in a superposition of dead and alive. Now here's the confusing part. If we open the box and look inside, we'd always find a live cat, or an exploding cat, never something in between. That's because, by looking at the cat, we've forced it to settle into one of its two states. Okay, so maybe that sounds dumb. Of course it would be dead or alive. So what's the deal about it being both? Quantum-sized particles, like electrons, actually behave that way. They live in multiple states, but cannot be measured or seen that way. As soon as we measure an electron's position, we find it in one state. But that's because we've forced it into choosing one state by measuring it, like looking at Schrodinger's cat. It's both dead and alive until we've checked whether it's dead or alive. If you think this is crazy, stupid, confusing, or some superposition of the three, don't worry, you're not alone. Even Einstein thought this was ridiculous. If you ever want to fully understand what Schrodinger meant by the cat in the deadly box, just become a particle physicist. It's as easy as that.